Hello students, welcome to Sourav sir's classes. This video is Matrix Part 3. In previous video, we learned about addition, subtraction and scalar multiplication of matrices. In this video, we will learn about multiplication between two matrices. The two matrices AB are comfortable for product A into B if the number of columns of A, that is the pre-multiplier, is same as the number of rows of B, that is the post-multiplier. Thus, if A is a matrix of order m by n and B is a matrix of order n by p, then their product AB is a matrix of order m by p and its elements are defined as aibij is equals to summation r is equals to 1 to n air into brj, which is equals to ai1 into b1j plus ai2 into b2j plus so on till ain into bnj, that is the sum of product of elements of ith row of A with the corresponding elements of jth column of B. Now, let A be a row matrix. Now, if A is a row matrix with elements A1, A2, so on till AN, and B is a column matrix with elements B1, B2, so on till Bn, then AB is equals to A1B1 plus A2B2 plus so on till ANBN. Now let us solve the following question. Here we have to find the value of x for which the matrix product given by this is equal to identity matrix. Now identity matrix of order 3 is as this: 1 0 0, 0 1 0 and 0 0 1. So the first element is 1. Therefore, 2 into minus x plus 0 into 0, that is 0, plus 7 into x, that is 7x, is equals to 1. This implies 5x equals to 1, or x is equals to 1 by 5. So we have the value of x is equals to 1 by 5. Now matrix multiplication also have some properties. The first property states that matrix multiplication is not commutative in general. It is not commutative in general. That is, AB is generally not equals to BA. Second is the property of associativity. It states that product of AB and C is equals to product of A and BC whenever both the sides are defined. Next property states that it is distributive over matrix addition. That is, A into B plus C is equals to AB plus AC, and A plus B into C is also equals to AB plus AC whenever both the sides of equality are defined. Next is the property of existence of identity. Now, if A is a matrix of order m by n, then Im, which is the identity matrix of order m into A, is equals to A, which is equals to A into identity matrix of order n. Fifth property states that product of two matrices can be null matrix while neither of them is the null matrix. That is, AB is equals to 0 when A is not equals to 0 and B is not equals to 0. For example, suppose our A is equals to 0, 0, 0, 2 and B is equals to 1, 0, 0, 0, then our AB would be, first would be this 0 into 1 into 2 into 0, so it would be 0. Second is this into this, so it is 0 into 0 and 0 into 2. Third is this into this, so it is again 0, and fourth is 0 into 0, so 0. So AB is equals to 0 where A and B both are not equals to 0. Next property states that if A is a matrix of order m by n and O is a null matrix, then A m by n into O n by p is equals to a null matrix of order m by p. Similarly, O into p by m into A m by n is equals to a null matrix of order p by n. That is, the product of a matrix with a null matrix is always a null matrix. Product of a matrix with null matrix is always a null matrix. Seventh property states that if AB is equals to 0, then it does not necessarily implies that BA will also be equals to 0. For example, suppose our A is equals to 0, 1, 0, 0 and B is equals to 1, 0, 0, 0. Then our AB is equals to, first this and this, it's 0, this and this 0, 0 and 0. But our BA, which is equals to 1, 0, 0, 0 into 0, 0 1 0, this is equals to 0 1 0 0, which is not equals to a null matrix. Hence, our AB is equals to a null matrix, but BA is not a null matrix.